Year 12, higher level biology, mid-course exam, paper 1b, last question, question 5. And here the stem of the question is telling us that this is the oxygen dissociation curve for a couple of types of hemoglobin, including fetal hemoglobin and adult hemoglobin. And we also have a dissociation curve for those people who have the condition called emphysema. Of course, like any oxygen dissociation curve, we have the partial pressure of oxygen on the x-axis and the percentage saturation of hemoglobin on the y-axis, and the characteristic sigmoidal curve, and notably the fetal hemoglobin curve lying to the left of the adult. And you'll recall that the phrase associated with this is that it has a higher affinity for oxygen. So let's see what the question would like us to do. And so it's asking us to state where in the body blood would be flowing at point X. So let's just pull the curve down so we can see it clearly. Here's the X. And the clue to doing this is to come down to the x-axis and notice that we're operating in some kind of value. We could measure this off accurately and determine that it's round about between 13 and 14 kilopascals of pressure of oxygen. So where in the body would such a high partial pressure of oxygen exist? And the answer is in the lung, or indeed in the alveoli. So we can go back to here and we can just simply enter lung. That would get the mark, or alveoli. A little bit more precise to gain this first mark. Just hesitate for a moment on that, just to show you that another way to look at this is to go, in fact, across to the y-axis, and there you would see that the percentage saturation is kind of somewhere between 97 and 100%, again, consistent with lung tissue. Outline the reason that the curve for fetal hemoglobin is to the left of adult hemoglobin. And of course you'll recall that I've made this point already. Sorry to scroll up and down, I know it's distracting, but here's the fetal hemoglobin to the left. And what this shows us, the classic phrase in physiology, is to state that fetal hemoglobin has a higher affinity for oxygen. That's a statement about fetal hemoglobin, HbF. Or you could attempt to make it more of a descriptive account, and that is the idea that the oxygen moves from maternal blood to fetal blood, and that would occur in the placenta. So that second kind of more descriptive approach works. Classic approach is here. 1 mark. It then asks us, what is the structural difference between the tetramer of fetal hemoglobin and adult hemoglobin? Tetramer just reminds us that there are 4 components to hemoglobin, 4 heme groups, and this is useful. Fetal hemoglobin has 2 alpha heme groups, so 2 of these components are heme alpha, and 2 of them are beta heme groups. Contrastingly, the adult hemoglobin has 2 alpha and 2 gamma heme groups. And so the difference, which is what the question wants, is between the beta and the gamma groups, which are here. 1 mark for that explanation. Moving on to this image here, which, let's look at the stem. So the micrograph shows mammalian lung tissue in its healthy condition, that's this one here, and with a condition called emphysema, this one here. So I think it's always important for students to spend a moment at least making that comparison before proceeding to the actual stem of the question. You can see that clearly the alveoli spaces here are much larger than the ones over here, and that would tend to suggest that you have a large surface area here, you've got a reduced surface area here, and that must be making you think about the efficiency of gas exchange. But let's take a look at the stem of the question, which is just here, and it's actually asking us, using the micrograph, describe one difference between healthy and emphysema lung. So a number of things that we could go at just by looking at the two images. Perhaps you might say that healthy lung has more tissue than the emphysema one. It's got more cells visible, certainly. You might go back to the point which I previously made, is that the emphysema lung, the alveoli are larger. I think those are the two major issues that you might raise there, and that will bring you a mark. And then to the final section of the final question, we're asked to explain how the difference you have identified, so which one of these did you do, will affect gas exchange in the patient. Now, it doesn't actually matter which one you choose, because the implication is always to do with the available surface area for gas exchange. That's the most obvious way to approach this. So if you might say, if you've got emphysema, you have less surface area for gas exchange, whereas with healthy tissue you have more surface area for gas exchange. It could be either way there, and that will affect the exchange of oxygen and carbon dioxide from the air and the blood into in the ventilation process, in the gas exchange process. Perhaps less obvious is that with less tissue, the lungs will be less elastic, and being less elastic means that elastic recoil is reduced. So this is going to affect ventilation patterns and tidal volumes, because we are explaining our way here. I think this really covers the major connections that can be made between this section and this section here. We're looking for 2 marks here, a connection with the difference to the one that has to address the one that you identified here. That's the end of the question. That's the end of the paper.